exam 2 review questions. Number 80. Question says, you have a series. Is it absolutely convergent or is it conditionally convergent? Exam 2 review. Question 80. So the series that we have is -1 to power j, -1 to power j, divided by ln of j plus 3, and j starts from 1 goes to infinity. 1 goes to infinity. So recall that we say that a series is absolutely convergent if you take the absolute value of its term, and that new series is convergent if the series of absolute value of an is convergent. Otherwise, we say that it is conditionally convergent. It is conditionally convergent. Okay, so let us analyze this. So we have to analyze two things, the original series and also the absolute value. And the series of absolute value of -1 to power j divided by ln of j plus 3. Okay, j starts from 1 goes to infinity. So if the absolute value of this guy is the series, so absolute value of -1 to any power -1, 1, -1, 1, the absolute value is going to be 1. So you get 1 divided by, and here you have ln of j plus 3, j starts from 1, goes to infinity. So we're analyzing these two series. This series, which is similar to an alternating series, we can apply different methods, and this series that is 1 over ln of j plus 3. So you need to check to see if this series is convergent or not. For example, for this guy, we can use comparison test or limit comparison test, whichever you feel comfortable working with. Comparison test. Here we can use integral test as well. We have ln, so we can do that as well. So one of these techniques, one of these methods, eventually working with these two series. So if we use comparison test, you can compare ln with the function j plus 3, and then since that series is divergent, this series is divergent as well. So it seems like it's a conditionally convergent series because this series is going to be a divergent series. And based on the behavior of this series is going to be convergent series. So it means that it is conditionally convergent. Your Bn is decreasing, it is positive, and if you find the limit is also 0, so you have a convergent series. Here you can just comparing this series with 1 over j plus 3, and you can see that by comparison test, you have a divergent series. Take a look at this. When we are talking about sequences and series, we have different cases. Let's write them down here, then we're going to discuss this guy here. So we start by talking about a sequence, an, f of n, and we say that, okay, these terms are dots in the plane. For example, an is equal to 1 over n. The terms of the sequence are 1 over 1, comma, 1 over 2, comma, 1 over 3, and the rest of them. We can visualize this guy this way. This is our n, and this is our f of n, 1 and 1. This is a half. Then here you have a third, a fourth. So as you can see, your sequence is going toward the infinity, and your terms are getting smaller and smaller. They're approaching zero on on x-axis. Your y is going to be 0. So the limit of this sequence is 0. This sequence is convergent to 0. We define a new object, which is a series, which is the sum of the terms of the sequence. Okay. Here, you have some initial techniques. The initial technique says, if you have a series and the limit of an as n approaches infinity is equal to 0, you are allowed to start analyzing your series. We can start discussing the convergence or divergence of this new object series. Okay. For example, for this case, you have series 1 over n. We need to construct the partial sums. Since the limit of an, while n goes to infinity, is equal to 0, we already know that we are allowed to go to step 2, analyzing this series. Okay, very well. So what do we have here? S sub 1 is 1 over 1, which is 1. S sub 2 is 1 plus a half, which is 3 halves. The number is getting larger and larger. S sub 3 is 1 plus a half plus a third, which is 3 halves plus a third, or 11 over 6, a larger number. S sub 4, 1 plus a half plus a third plus a fourth, which is 11 over 6 plus 1 over 4, or 50 over 24. If you continue constructing S1, S2, S3, S4, and the rest of them, the behavior of S sub n's is going to be, okay, 1, then here, here. This new sequence, S1, S2, S3, S4, S5, it's going to be larger and larger. So it goes to infinity. So this series is divergent. Okay, now think about your series -1 over ln of n plus 3. So here we have -1 over ln of n plus 3, and we construct a series -1 to the power n divided by ln of n plus 3. Okay. Well, okay. If we construct the terms of this sequence, if we forget about the -1, it doesn't matter. The limit of -1 to power n over ln of n plus 3 as n approaches infinity is equal to 0. We don't have any problem with our sequence here. This is our sequence, the terms of the sequence. They're getting smaller and smaller. If I plug in 1 here, I get a negative number. This line is going to be here, then here, then here, here. This is going to 0. They're approaching to 0. This is your sequence. I'm not talking about the series. Let us think about the series here. If you have -1 to power n divided by this guy, we know that the limit is equal to 0, this limit. Now we can start discussing the convergence or divergence of this series. Well, since this series is similar to alternating series, -1 to n minus 1 bn, and starts from 1 goes to infinity, and bn as 1 over ln of n plus 3 is decreasing. And the limit of bn as n approaches infinity is the limit of 1 over ln of n plus 3, n approaches infinity is 0. Based on the alternating series, this series is convergent as well. You can also use a calculator, calculate the terms of this series. S1 is -1 over ln of 4. S2 is -1 over ln of 4 plus 1 over ln of 5. S3 is -1 over ln of 4 plus 1 over ln of 5 minus 1 over ln of 6, and the rest of them. This new sequence of the terms of the series, they are also convergent. So if you just graph these, the very first term is going to be the same, then you're going to have the next one, are we going to behave similarly? It's going to be going toward the 0. Okay, now, if we don't have the -1, we need to check to see if the absolute value of the terms are convergent or not. So let us forget about this -1. What do we have here? The absolute value. 1 over ln, 1 over ln. So as a sequence, the limit of this sequence, 1 over ln of n plus 3, as n approaches infinity, 1 over infinity is equal to 0. It means that if you start graphing these, your terms, all of them are positive. 1 over ln of 4, 1 over ln of 5, 1 over ln of 6. The rest of them, it's going to be decreasing sequence. What if you form your series? The limit of an is 0, definitely. Just showed that using elementary calculus. Now we can discuss convergence and divergence of this series. You can use integral test, or you can just find S1, S2, S3. S1 is equal to, okay, the very first term is 1 over ln of 4. S2 is 1 over ln of 4 plus 1 over ln of 5. If you take the common denominator between these two, you get ln of 4 times ln of 5. And here you get ln of 4 plus ln of 5. You get a fraction. The behavior is very similar to your harmonic series. S3 is 1 over ln of 4 plus 1 over ln of 5 plus 1 over ln of 6. And you can continue this process. If you use your calculator, write down each of these numbers, the behavior is going to be like this. This is S1, S2, S3, S4, S5, S6, and this new series, this new sequence out of this series is divergent. It's going up. So question 5 says, well, we have the Sn be the n partial sum, like Sn, the S1, S2, S3, S4, Sn, and your series sigma. AK, K starts from 1, goes to infinity, is 8. And the question says find the limit of AK. And it asks to find the limit of Sn as n approaches infinity, as k approaches infinity. So first of all, this guy says our series is convergent. This means that our series is convergent. When the series is convergent, the limit of the general term must be 0. So the limit of an as n approaches infinity must be 0. It means that the limit of ak as k goes to infinity must be 0. If the limit is not 0, we cannot discuss convergence of this series. So since the series is convergent to 8, it means that the limit of general term is 0 for sure. It also says, hey, what is the limit of partial sum? Remember that this is how we define the convergence of a series. When we talk about a series, we say that a series sigma an is convergent to a number like L, alpha, beta, whatever you want to call it, if its partial sum is approaching L. Approaching L at infinity. Well, okay. It says, hey, my series is convergent to L. This is your L. Your series is convergent to L. By definition of a series being convergent, it means that the limit of its partial sum must be L, in this case, 8.